Hi, my name is Foad Hamidi, and I'm a PhD candidate in computer science working under the supervision of Professor Melanie Balco in the Department of Computer Science and Engineering at York University in Toronto. This presentation is about my recent research projects. Technology affects every aspect of our life, and its influence is oftentimes inevitable. An important question is how can technology be used meaningfully? The general theme of my research is using technology, and specifically digital media and computational systems, for empowerment and inclusion. I will briefly talk about 5 different projects that revolve around this general theme. The first project, CanSpeak, is an assistive tool to facilitate communication and computer interaction for people with severe motor disabilities and speech dysarthria. One of the areas in which technological advances have undeniably helped many individuals is assistive technology, the design, production, and deployment of technological solutions for users with disabilities. The development of effective augmented and alternative communication systems, or AACs, is an important area of assistive technology. Stephen Hawking, the famous British physicist, is a scientist and theoretician who has used AAC to communicate his brilliant ideas for years. We can only imagine what a loss it would have been if such technology were not available for him. Software scanning keyboards often form an important part of AAC. Selectables are organized in rows and columns of elements which are periodically highlighted. The user selects an element by repeatedly selecting the highlighted group that contains it. Using this method, text can be composed using 1 or 2 physical switches, or other alternative input methods, such as puff switches. For my master's research project, I devised an information theory and linear programming method to analyze and compare different scanning keyboard designs with each other. The method, called the reverse Huffman algorithm, views a given scanning keyboard as a deterministic finite automaton and extracts a containment hierarchy, which is a tree that expresses the relative position of the selectables from it. By extracting a representative probability distribution from this tree and comparing it with other designs by calculating the Jensen-Shannon divergence between them, the method provides a way for a priori design and analysis of scanning keyboards. After this theoretical research, I started working on a hands-on project under the supervision of Dr. Nigel Livingston and Leo Spaltholz at the CanAssist Research Group at the University of Victoria. Work on this project continued later on during a collaboration between CanAssist, York University, and Participation House Markham. The initial goal of the project was to develop a small vocabulary speech interface for users with speech dysarthria. By selecting keywords that were customized for each user to be easy to pronounce for them, the CanSpeak interface allows users to compare text or navigate the web using their speech. While developing this project, I was able to work with users who shattered many misconceptions I had about users' needs and capabilities. For example, one of my colleagues, Dan, at CanAssist, has cerebral palsy and dysarthric speech. He is also a computer programmer and an avid user of email and social networks. Through my interaction with Dan and other users of the system, I realized the importance of taking into account not only the individual user, but their community and the ecology in which they live and work. This awareness of the community of users brought me to my next project, our digital Tapestry. This project was motivated by the observation that perhaps technology can provide people with expressive freedom and new means of collaboration and expression. I have many friends who are artists, musicians, poets, and filmmakers. Many of these friends live in the Middle East, where access to an international audience is very difficult, if not impossible. As an artist living in Toronto, I've had the opportunity to perform live on many occasions and realize the importance of having an audience. Regardless of how large or small an audience is, its existence is vital to vibrant and inspired artistic activity. Additionally, being in a large music band, Sacred Balance, made me aware of the importance of artistic collaboration and the range of expression and artistic power it makes available to participants. These ideas led to the creation of our digital Tapestry, a collaborative poetry project on the Facebook social network. The project started with an invitation to collaborate on a series of short poems that I posted on my Facebook page. After the first poem was posted, the project started to grow and grow, turning into a multimedia, multilingual, collaborative poem. Over 4 weeks, 19 participating poets from 5 cities across the world contributed to a poem, which was written using 2 languages and 3 scripts and incorporated videos and images. By being directly engaged with the participants, I assumed an artist-researcher role, which allowed me to find subtle emotional, psychological, and intellectual aspects in the creative process of the project. Additionally, I used autoethnographic methods to report my experience as a participant as well as an investigator in the project. Several aspects of social networks were identified that make them useful for creative collaboration, including support for performance, communication between participants, support for internationalization, and diversity, among others. As project leader, I realized the importance of creating trust in intercultural collaborations. This experience led me to an examination of another collaborative project that a good friend of mine, freelance filmmaker and photographer Foad Hamidi, was conducting in Haiti. Haiti, Children of Heaven's Eyes, is a documentary film with a strong web presence about the aftermath of the 2010 earthquake in Haiti. Foad works closely with different community projects within Haiti, from tent cities to private schools and community initiatives. His aim is to empower Haitian children, activists, and artists with a voice and presence through digital media and web presence. To this end, he has created a companion website for the film, in which he posts video profiles of Haitian activists and artists, along with their direct contact information. A key observation during my trip to Haiti was that what makes Foad's project possible is a close and trusting relationship with local members of the community with valuable resources and knowledge who are interested to help and collaborate with development initiatives. People known by development experts as human access points. The idea of collaboration through technology formed the basis of another project, Synchrum, a tangible interface for rhythmic collaboration. When traveling in China and India, I became aware of a fascinating cultural object, the Tibetan prayer wheel, which consists of a cylindrical chamber mounted on top of a handle and fastened with a weight. A prayer is written and placed inside the chamber, and it's traditionally believed that each rotation of the wheel corresponds to a recitation of the prayer. What fascinated me about this object was its physicality, and that it added a performative aspect to praying. Engaging the audience of digital performances is sometimes challenging, and I was inspired to develop an object that would facilitate participation and engagement. The first prototypes were created out of existing objects from a most inspiring environment, the home kitchen. A potato smasher, a yogurt container, and a chair wheel were used. Working with Professor Melanie Balko, Alexander Moakler, and Asaf Gadot, we created Synchrum, a wireless computational object that consists of a rotating weight that blocks a light sensor, allowing for the monitoring of its rotation patterns during interaction. We designed a video installation entitled Liberation, in which members of the audience could release virtual locks connected to a performer by synchronizing their movements together. Finally, my PhD research project involves the development of Rafigh, Persian for body, a tangible computational toy for speech intervention for children. Research has shown that early speech intervention can help alleviate many forms of speech disorders. A typical intervention setting involves a speech-language pathologist or SLP engaging a child in exercises and providing them with feedback. This model is repeated in computer intervention systems that provide feedback based on input speech for children. However, automatic speech recognition, or ASR, has proven to be inadequate for the analysis of speech errors, and the feedback from these systems can be erroneous and inconsistent. Other approaches, where ASR is used to engage rather than analyze speech, have been more successful. Recent years have witnessed the prevalence of tangible and embedded interfaces, or TIs, a new wave of computational interfaces that aim to transcend the desktop computing model. TIs support new interaction methods, such as grasping, moving, and touching smart objects, making them ideal for developing applications for children. I combine ASR and TIs to develop an interface that allows children to interact with living things and provides them with control in their interaction using their speech and touch. The first prototype engages the child in the care of a living mushroom colony in the home environment. The speech used during interaction is recorded and monitored later by the SLP. We believe that this web interface will be engaging, motivating, and meaningful to interact with. Thanks very much for your attention. Please contact me for any further questions or feedback about the research project.